Hello guys, this is George Bunjet with Murray State University, and today we'll start taking our first measurement by using our ultrasonic sensor for distance measurements. I put here on our page another web page where I started to explain about these measurements and the sensors that I use, and basically I searched, I presented the mechanism related to these type of measurements, acoustic measurements, and then I went ahead and searched for the data sheets. As you guys see, that is one of them. This is more accurate that is in the data sheet because it appears that is not one clear data sheet. Every one that manufactured it put a different data sheet, and including the ones here are making some mistakes in them, as you will see if you check it. Then I explain here how the sensor should be connected, and put the diagram here using fritzing, and you guys can see the connections. I explain also here what are each of the pins. Of course, I did not talk, I forgot to put it about ground, but that makes obvious. As you can see, we connected it there at the ground pin. Here we have several ground pins, each one of them will work. I did use this one next to the power pins. So if you're not familiar with the breadboard, how the breadboards are working, I put the image here, and I hope this is clearly explaining what is going on in there. If you don't have you have questions, please let me know. Then as you can see, we have to excite the sensors, and that means that we use the Arduino hardware, the Arduino board, and also after we wiring it up, of course, and we have to put this code into the Arduino and load it in the board. And as you can see, we are triggering using the pin 13 to trigger to excite the transmitter, and then as we know, there are two sensors there. One acts as a transmitter and one as a receiver. So it's a pitch catch type of measurements that is called in ultrasound in this way. So the echo is received at pin 11, and the way we are exciting, the way we were using a sort of ultrasonic square pulse that we are giving it there, and this is how we trigger the pin low, and then we trigger it high, wait a little bit and trigger it high, and then again low and again. So then after that is similar, like we do some conversions. So we have based on the time of flight of the ultrasound, so we can get the distance based on the sound velocity, and that is transmitted to the serial port. Then of course we are going to use Python to grab this data from the serial port, plot it, and then save this data so we can later analyze it and make a decision about how good this sensor is. It's more explained here about this code that I've written, and it's based on, we built on the previous code that you guys were using in the previous assignment. So the only part that is new from what I recall, it's I added here the try structure, try in the sense that I don't want to go forever. I want to get out safely out of this loop, and that's why I'm putting here in the shell I have to press Control C to terminate to get out of the while loop, but not losing the plot and not losing the data. So I'm getting it nicely in such a way that the data is saved, and this is another part that is there. We save it with 3 decimals and we put it in a CSV spreadsheet, so it's an easier way for me. We could have used Excel also. And don't forget to change the name. Here I'm using an aluminum block. You can do some other measurements with other blocks, whatever, but anytime it will overwrite. So if you want to save multiple files, then you have to change the name of the file, because otherwise you will lose the previous file if you leave on the measurements. Let's go to Python now, and right here, so you can see the code is there, exactly the one that you have on the website. So right now I am, as you can see right there, at 1 inch away from the sensor with the block. So and that doesn't do good, because the sensor is supposed to work perfectly, I mean good, from 2 inches up. So we'll have to see if that's true or so, and we'll run this, and we start acquiring points, data points, and then we move it. As you can see, it gives me some erroneous values. If after I'm getting 5-10 points for this, I'm gonna move this block to 2 inches right here. So, and you see that I have to wait a little, because it took me a while until I got to 2 inches, and I got it 2 inches and something. So after I grab a number of points, I'll go to 3 inches. So you can see that it's not exactly measured perfectly, and the reason I will show you what I discovered. That's one reason of this is not giving exactly absolute perfect value. So from 4, you can see I also have some variation there. It's supposed to be 4, and it's not exactly 4. So then we go to 5. So you can see it's less, a little bit has the tendency to be, although I have some distance there. And again, my ruler here stays well somehow fixed, but everything has to 6, it appears to get better measurements. So all I have seen is that the orientation of the block is the one that dictates. Say, for example, I am at 6 right now. If I am tilting this a little bit, you can see that I start to have more increase in the distance. Even more, you can see that the part of the data provides some erroneous results. But of course, this is quite significantly tilt that I am giving here in order to get. So the sensor performs relatively well. I still don't know. So it went back to 6, as you can see. If I orient it to be perpendicular on the waveform, and now you can go, and again we can take these measurements all the way to, like, say, of course it will be like 13 feet. We'll not be able to, each one of us, to do that. So I think if we go all the way to 10 inches, 12 inches, that would be quite well and good for this, to assess the accuracy and get the first set of measurements with this. After we are done, we went all the way to the end. Then we were gonna save the data, and that means we have to get out of the while loop. So I have to basically come here on the shell, click there and say Control C, and it will, as you can see, it terminated well the data. And if I am going right now in my spreadsheet, that I think I put it in, let me see where I have it in here, distance with the aluminum block that I have there. And I'm gonna grab these 2 columns and make a plot there. Let me see if I'm able to do that. Like this, you can see that I'm kind of reproducing my plot that I had it with Python. So this definitely shows me that my measurements were good. So they were the real one recorded, and you can see I also put a header for the table there. Of course, that's coming in the Python code. I'm not need to save. Don't save this because it's already saved. I don't override save the plot. But I hope this works well for you, and I'll put the assignment on the canvas so you can see how, of course, how you take the measurements. I do encourage you to use orient the sensor so that it is vertical, perpendicular, parallel, the wave travels perpendicular to the wave. Use whatever block. I do have a block of wood here, and I also have a block, plexiglass. whatever blocks you have at home, and or even books can work for this type of measurements, and whatever ruler you have to just put it on table. And I recommend to move in steps of 1 inch, and based on this we'll perform some statistical analysis. We can see the level of accuracy of this transducer. I hope everything works well. If you have questions, please let me know. My email is gbunjet@marinestate.edu. Thank you.